All right, welcome to the build. So it's moving quickly.
And their product velocity is intense. We're both pretty involved in the LangChain community.
This is going to be an industry, like the whole thing is going to explode.
The hype cycle, it's like just because you hear everybody start talking about these things doesn't necessarily mean it's the right.
Need to go back, find out more because it's really interesting.
We're both obsessed with AI and their entire stack is just pivoted to agents.
The next question that usually comes after that is like, well, I'm fine-tuning an open model.
That's the biggest thing with the latest spec.
It's an exploding distribution vector.
I'm really excited. I think everybody is. I'm not the only one.
The build.
Yo. Hey, can you hear me? Hello?
Yeah, man. You can see my beautiful face. And I can see yours.
Exactly, man. I don't want to miss out.
All right, let's get going. So, yeah, how have you been this week? My long-lost friend that I've spoken to 100 times.
Good. Really good. Working on some projects and getting ready for this discussion. So hopefully some good information. Yeah.
Yeah, we did try our best. Yeah, man, I'm pumped for this conversation. I'm pumped for the episode today. There's a lot to go through. I'm also pumped. I'm going fishing on the weekend, actually. I'm pumped for that. I'm going for some man time out in the bush.
Are you a
with
big
my son.
fisherman?
No, I'm terrible. I have no idea what I'm doing. Idea. I'm about to go to Bass Pro Shops and spend all my money on stuff that I don't know how to use. I've got
That makes it more fun, though, actually.
But yeah, no, I'm pumped for that. Just go out for a bit of man time, sit around the campfire. It's going to be sick. Anyway, let's get into what happened this week.
I'm excited for you.
What, did you see anything cool before we get into the episode?
Yeah, like the new models. I guess we already covered Grok 4 last week, but you have a lot of good information on Kimi. And I think that was the main one.
It distracted me a lot this week, this Kimi thing. Like, I don't know if you're on X seeing like it flow through everyone's channels and everyone was talking about it. So yeah, I thought we might as well talk about it.
Tom, what have you found out about Kimi so far?
So this Kimi model is pretty cool, mainly for the way that it was built and created is what I found the most interesting. It's from a Chinese lab called Moonshot. They have released other open source, open weight models before. This one's probably the highest performance one, and it's a non-reasoning model. And it outperforms Seek and some of these other open source models. And then it gets close on some benchmarks to some of the closed models. Specifically, it gets quite close to Claude Sonnet on coding at about 80% of the API cost. 80% reduced API cost relative to the Claude models. And so a lot of the things that I found this week when I was going through some of the docs and some of the information is just people trying to get it running in Klein or in any kind of coding tool. And then a couple of the API providers cropped up, and the best one being Grok. So everyone was like, oh, this is super slow. But if you get it running on Grok with a queue, which they do have, it's blazingly fast and excellent. So I might just pull up some of the documents so we can have a spin through them. But yeah, did you see anything about this?
So yeah, it's like the model it's massive, right? Like I think I saw it was like, if you want to download it, it's like 350 gigs to download. Is that right?
Yeah. So it's ginormous.
Of course, you're not.
It's absolutely ginormous.
You're not running that at home or on your computer. I mean, you have to have some serious hardware to run this.
Seconds. Yeah. So this is the launch, effectively like the launch report from Moonshot. And yeah, you're right. Like you don't run this locally. Although, if you did want to, Unsloth, if you've heard of Unsloth, they're like a fine-tune optimization kind of open source project. They did release this local version to get it running, but it's still, even at reduced size, it's 245 gigabytes. The total model requires about 1 terabyte of disk space to run. So it's massive. It's a 1 trillion parameter model. So, which is pretty insane. So there's a total of 1 trillion parameters, but they use this specific kind of innovation around a mixture of experts, like sparse attention model. So it's only ever 32 billion parameters that are activated at once. So that's the actual effective size. But yeah, it's ginormous, mainly targeted at coding. And then there's this Kimi2 instruct version. And you can see the main thing to call out is basically this, like compared to, it's actually Claude Opus comparison, not Claude Sonnet, pardon me, versus Kimi2 instruct. Like that's pretty amazing given that it's an open source model. Multiple versus single attempts at SWE bench verified benchmark, which is generally the most commonly cited benchmark for coding, right? And you look at DeepSeek down here. Yeah, that's amazing. The only other
I think
thing
that
on
the
that I
thing that
wanted
stood
to,
out to me, apart from the benchmarks, was, and you might be getting to this next, but the 2 million token context window, right? That's kind of
I
like,
saw that. Yeah, I saw that, but then it was conflicted. There were conflicting reports on some of the API providers saying it was like 160K. So I don't know. I'm confused about that. Like, is it real? Is it not?
I hope it is. That would be, I mean, and that's bound to happen. But I think that would be the most of any model that I know of, if that's accurate, right? I mean, by the, maybe by 2 times, because Google GPT-4.1, they have 1 million. So
I think it's effective context windows. So yeah, I think like practical usable context windows like Gemini and then 4.1, GPT 4.1. Whereas Llama 4, I think, came out with like a 10 million context window, but effectively it wasn't really functional. Like they were talking a game about it, but it didn't really pan out that way.
right.
The only other thing to call out on this is what I found really interesting is this part here. So, whoops, where they highlight, basically they say like agentic use cases was something that they were really trying to optimize into, and specifically the developer experience and the developer usage of this model in agentic apps. And they cited these 2 papers, one of which is sort of more interesting, is this error of experience. So these guys, error of experience is an interesting kind of paper. And I'll share like a YouTube video in the show notes from Google DeepMind, specifically about this, basically where he says, look, we're running out of tokens. We need to figure out a way to generate synthetic data that's effective for pushing the frontier of intelligence in these models out. That's the high level concept. And then Google DeepMind has a couple of specific projects. You would have seen some of them coming out. You know, they had that biology or like biology and chemistry model. They also have like Go Zero and some of those models where they effectively were able to get the model to generate its own synthetic data in order to learn to play chess and then some other games, and then also math. So they actually did it with math, solving math problems for the Math Olympiad. No training information, just runs of execution in some sort of reinforcement learning environment, right? So these guys took that and actually built that into the training program here. And what I've found really cool about this is that they did it specifically for tool use, using real examples from developers like us. Like, so they got MCP examples and ran through multiple use cases across multiple tool calls to generate just an absolute bucket load of synthetic data, and then had a rubric judge, LLM as a judge, function over the top of all of that synthetic data to benchmark out the quality, and then push the model through a reinforcement learning process on that synthetic data in order to make it as good as possible at tool calling and an agentic, basically a model that could be put into an agentic framework like a coding environment, like a Claude Code or a client or whatever, so that it excels at that specific task. This is really cool because it's the first time I've seen an AI lab take the requirements or the needs of developers into context when building the model. Whereas in the past, it's basically like, all right, give me everything on the internet and give me just an absolute shitload of Reddit posts and a bunch of other stuff, and I'll just kind of get a prediction out of it or put it through a reasoning flow. Where this is not a reasoning model. This is a model where they just try to make it as good as possible for developers to use in specifically in the context of how the market requires these models to function right now, for example, using MCP tools. Like, that's really cool. I don't think that's happened before.
Yeah.
At least.
Yeah, I think if that's something that's probably taken for granted. I mean, if you're not someone who works with AI every day or is on top of these models, it might be even surprising to some people that you're having to, especially at this point, we've talked so much about MCP and all these different tools, different frameworks, but it actually is a fairly recent development that we have models specifically trained to be able to do tool calling really well. And now it's funny, I don't even think about it, but it wasn't that long ago that you'd have to be pretty selective on the way that you're designing things, what models you're using, what type of tools, because a lot of them, the models were not even capable of that.
Yeah. Yeah. And the way that was sort of solved for, correct me if I'm wrong, solved for prior is just the model raw intelligence was very good. And then the dev tooling on top for the tool calling got better, right? This is the first time I've seen
Right.
where it's
Yep.
actually they're trying to embed it into the model as a piece of kind of intellectual grunt that you can call on. Basically, great at tool calling in the context of how tools are built by developers in like an AI engineering context, which is pretty interesting. It also, I think, shows how the developer community, like has happened in the past for, almost every tech wave, the developer community shapes the direction of the tech. It's not like the developers are not just receivers of it; they're sort of influencing the direction. I don't know. It's an interesting thing. We'll see if that process actually gets embedded by some of the other frontier
Yeah.
labs.
You talked about the medical agent, and that they were specially training a model for like in-depth medical knowledge, right? And so that's what you were kind of saying earlier. The models earlier on, they were trained for deep knowledge, basically of the internet. Um, that model you showcased the other day, very similar. It's trained specifically on deep knowledge of the medical domain. But you're saying, like, would you compare what you're saying with Kimi? It's like the developer version of what you talked about with the medical agent. I don't know if
So with the
that makes
medical,
any sense to you,
yeah,
but
no, it makes perfect sense. So with that medical demo that I did, or that was based on a paper where those researchers were using frontier models. They weren't fine tuning them, but there are other examples where they were trying to fine tune or like customize a model based on specific data sets, medical data sets. Right. But, and that was sort of like, remember 2 years ago when all of this was like really kicking off and the frontier models were getting good, everyone was like, all right, we're going to have fine-tuned models. Everyone's going to have fine-tuned models. There's going to be a fine-tuned model on finance data that's going to work. But none of that really panned out. It was just the models got bigger and more capable and just smarter. And that blew every kind of approach to specific fine-tuning out of the water, except for very, very narrow band tasks like what the Cognition guys talked about, where they fine-tuned a model just for CUDA kernel development applications. Like, you can't get much more refined and specific than that. Or in the case of, say, some of the science applications, there's very narrow band fine-tuning that occurs. This, where everyone else, basically all the app developers like us, basically went to the point of saying, if you have a really good eval set, then you don't need to fine tune a model. You can use that eval set to optimize your way into a great user experience or customer outcome. And if you need, low rank adaptation, like very cheap kind of fine tuning for specific tasks. This is different in that they basically took into consideration how the users of the model would want it to function and put that into the training set in a very specific way, which is kind of different, I think, to the fine tune kind of approach. It's like juicing up juicing up the experience of the model in the era of experience, focusing in on developers and how developers will use it, as opposed to, say, people who just want to chat with it, which I thought was different. I hadn't seen it before. Yeah, so if you want to use it, you can use it on this platform, their platform, and apparently that's super slow. So you can use it on Grok as well. Show you that. Let's go around here. A couple of the other things that I found kind of interesting about this, and I'll put all these in the show notes, is that, oh yeah, here's the artificial analysis breakdown. You can check that out yourselves. But is this Perplexity basically said, look, this model looks pretty good. We're going to start post-training on it, because Perplexity creates their own kind of post-train open source models for specific tasks, which I thought was pretty cool. He basically came out and said, as a couple of days or a day after it sort of appeared, he's just like, yeah, all right, we're definitely going to post-train on that, which is pretty rad. Yeah, sorry, did you have anything else you want to say?
That's pretty. Yeah, you mentioned the Perplexity thing, and I think it's just wild from like a product standpoint that now these companies are, and I guess that they probably have a heads up. I guess it depends on relationships, but just that quickly, like something comes out and these model providers are like, are we going to provide that or not? And then like within the same day or the next day, they have it running and available. I think that's kind of wild.
Yeah, it's pretty amazing. I don't actually know the process that they have to go through to get these things online. I'm assuming it's not trivial. So the fact that if they don't have a heads up, it must be pretty infuriating. Like, not many people had a heads up about DeepSeek, right?
Right. Yeah, but
Yeah,
they
so
had
here it
it,
is
a lot
here.
of the providers had it on, it was like next day.
Yeah. You, Kimi, that actually works.
Yeah, Grok has a really cool playground. And even
Like, all right, that actually did work. Yeah, it is really cool, actually. I haven't played with this very much.
he said, what are you?
What are you?
And
And it says,
it
I'm
can't
Kimi, your
respond to
intelligent
that.
assistant.
Oh, I'm Kimi.
No, I said, I went and put
Help me.
in the system prompt, I said, you are unhelpful. Well, it's very literal. That's a very literal. Yes, I'm sure. All right. Yes, even for Grok, that's pretty slow. So the latency there's pretty. I'm keen to try this. So I've seen a couple of people get it up and running and connected into their Claude code instance. So the CLI tool, and just replace the Claude models with Kimi, even though they're using the Claude CLI, which you can hack it. Which is pretty cool. Cool. Do you have anything else on Kimi before we move on?
No, have you seen any like demos or people talk about specific things that they've been able to accomplish with Kimi, or like different areas of coding that it's, or too early?
Not yet. Not yet. Everyone that I've seen putting it through is just like, here's how to get it up and running. And then people just saying, like, giving it one shots, basically. So, which it's hard to evaluate something just off like how many 3JS games can you build. I think the real test I want to do, which maybe I'll come back to you and show you next week, is I want to overload it with like 30 to 40 tools and just see what happens. Because one of the key critiques of models that are poor at engaging with tools is that if you have lots of different tools, and even if you have great meta descriptions on them when the agent should call it, they still get overwhelmed and call the wrong things or make the wrong decisions. I think that would be the ultimate test of this, is to say you can just throw hundreds of tools at it and it makes the right decision based on its training data. If that's true, maybe it's not true. I'm not sure.
Yeah, well, we'll find out. And like you said, it's so hard. You might see a demo online, and that's just one example, but it's so hard to really evaluate them because they have different behaviors, right? Like you mentioned that cipher model, the mystery model that was on OpenRouter, right? And I tried building a couple things like even simple tests. I was like, this has to be a joke, like it's not a real model, or I just don't I haven't read enough about it to understand like what is it actually for? Am I just completely using it wrong? And that could be the case too, you know?
Yeah, so I heard about that, and so that was pulled out of OpenRouter, and then I saw this on these reports on. Well, there's a lot of news reports on this, but basically, Sam Altman was a bit disappointed at the performance of it, so pulled it or has delayed it, which effectively means that it has been pulled from OpenRouter, so you can't use it anymore. But it's funny that you you say that. Like, what was wrong with it? I mean, I didn't even try using it. So what was the problem with it other than it feeling like a joke?
It it couldn't do just like really basic things. Um yeah, so that's where I was like, maybe this is meant to be layered or used in a combination with other models or at a certain layer in your process, and I just don't realize that. But um I was also testing it with I did a couple different things. I did test it within Klein, the coding agent for VS Code, and that could be another issue because that's a whole nother layer of logic layered on top, right? And I've had that before, so I can't really say, but what I do know is right out of the gate, like right away, I was like, huh, this is GPT-5 potentially. I don't know about that. Like could have told you that right away. So we'll see. We'll find
I
out.
don't. Yeah, I don't think it was. I definitely don't think it was GPT-5. Um, just based on some of the parameters that the model had in there, it looked more like the open source kind of variant based on what they'd reported. A couple of other things I wanted to highlight before we jump into the discussion. Well, actually, something that is relevant to what we're going to be talking about is Gemini dropped a new embedding model this week, which is cool. I haven't tried it yet, but I'm keen to try it out when I can. There is also something that's a late entrant that I wanted to mention is this. So this is from a Substack called Clouded Judgment. I saw it shared on LinkedIn and it blew my mind. So I know this isn't specifically AI related, but it has a specific application to or specific relevance to the change in the software industry. This is an analysis. Someone did an analysis of public SaaS companies and their uh, CAC payback. CAC is basically just how much they spend to acquire a customer, and then how many months does it take to pay back that cost in ARR, annual recurring revenue. And it's used as a benchmark of basically how efficient they are and how good these businesses are. It's kind of like a benchmark of how good these businesses are. And so many of these companies have just seen all of their ARR, CAC payback periods blow out to incredibly insane levels that are completely unsustainable. And I think it talks to sort of the reckoning coming for SaaS in that, number one, many of these SaaS businesses are being disrupted. So companies that played in a certain space on a specific kind of enterprise long contract kind of economic model, many of them are feeling the pressure of that. But the other factor is the pricing model of many SaaS businesses is changing to be consumption based. So more towards the consumption model of, say, a Twilio or an API based product or things like that. So the fact that that is occurring means that so many of these businesses are just going to come under pressure. And also, it's a great place to look for opportunities. Like, for example, a company like Zoom is just in a net negative new ARR added bucket, or you've got, companies like Elastic, that sell the Elastic Stack, where their payback period is over 100 months. So over 100 months to pay back, you're looking at 8 years to pay back the cost of bringing on a customer. Like, that seems incredibly unsustainable. There's no way those businesses are going to survive, at least in the public market. Yeah, that's something I just wanted to highlight because it blew my mind. And
You're
I'll
saying
stop
their
presenting that.
average to that's their average. That's their average to basically make their money back on the pursuit and the sales cycle. Is that what?
Correct. Yeah. So CAC, it's not a public market metric. So companies calculate it differently. So it's hard to get consistent benchmarks. But CAC is basically you add up all of the sales and marketing costs to bring on a customer, and then you divide that by the time it takes to basically the lifetime value, the average lifetime value of the customer, which is generally calculated based on dividing your number of customers by your churn rate. But if you don't have that churn rate, you just take the average, and that gives you an estimate of the money you have to spend in order to pay back. Sorry, the time your customers have to be customers in order to pay back your marketing expense. Or on the flip side, what you can pay or what you can spend in order to bring on a customer, as long as it's a reasonable time period that you can cash flow. So a lot of these companies in that context, they're spending money. If they're in this 100 months payback period and higher, they're spending money to bring on new customers in marketing and sales costs, and they don't expect to pay that back for 8 years. Like, that's crazy.
Yeah, that's insane, man. Like, I worked in professional services for a long time, and I can tell you, like, that's not a new thing. That's always been the case. That's why it's so important on like contract renewals and things like that. You want the renewal. You have to get the renewal because it's so much more beneficial to your business than chasing opportunities all the time. I mean, sales cycles, of course, it depends on what you're selling, but in the enterprise space, I mean, you could talk a year, multiple years. You think about the number of meetings and travel costs, and I mean, there's so much that goes into that. So, yeah, sometimes I think that gets taken for granted how beneficial it is to keep your keep your existing customers. Some people just want to chase
Yeah.
the new and shiny, but that's where I mean, in a lot of cases, it can be make or break. You have to keep your customers. So I hadn't heard that 8 years. That's insane.
Well, yes, it is insane. So there's a couple of things. So like enterprise SaaS companies have always had a very long payback period. The reason for that is because there was a lot of cash flowing into the industry, and so they could afford to spend. So it was kind of like an arms race. That was number one. Number two, enterprise software companies generally had a lot of stickiness. So once you embed a solution into a big company, like, it's very challenging to get rid of it. So they had very long kind of lifetime potential. But just to have the payback point be so long for so many of these businesses. Now, it's not all of them. It's not all of these public SaaS businesses. Some of them are still excellent and they have excellent payback periods for enterprise SaaS, but a lot of them are blowing out. I have a couple of theories about it. One is, I reckon, just the IT budgets have swung so rapidly towards the AI spend space, and so many of these companies were just not ready to capture that revenue, but now they are. So we might see some of this improve. But the other factor is it doesn't capture what's called net revenue retention or net revenue growth, which is effectively like from your existing customer base, because this is gross CAC payback. So when they bring on new customers, but it doesn't capture when their existing customer base and the expansion revenue they get. So even if there's a very long payback period for new customers, if these companies are introducing new, say, AI enabled features specific to their use case, then they may be capturing net new ARR just from their existing customers. But it looks like some of them aren't, because they're still being called out in this blog post as having no negative NRR growth, or negative net revenue growth. Yeah, it's just, I guess the reason why I wanted to talk about it is I think, I was reading this and I'm just like, because I worked in SaaS for a long time, and when SaaS was really kicking off, that was one of my first startups, was in 2015. We really went hard in the SaaS space. Everyone was going for it. There was a lot of investor interest. It was very frothy, and I feel like, looking at this, I'm just like, I was wrong the whole time. SaaS isn't, the promise of the SaaS business model was basically baked into the companies that were in position in 2012, like Salesforce, and no one else is actually ever going to get to the panacea of the SaaS kind of promise, which is very high margins, embedded, at scale businesses. There's just going to be a massive graveyard of these SaaS companies that just slowly die through this AI wave transformation, because AI is now changing the entire game, pricing model, everything. Yeah, go on. What were you going to say?
No, I don't know. I have a intuition that there's been some delay in the progress in enterprise adoption, or I guess I'm thinking about Microsoft and organizations like that. Say Microsoft, they've always made their money on per user, per month, or annual, whatever, subscriptions, right? Number of seats.
Yeah.
Well, everyone's talking about potentially reducing headcount. I thought of it right away. I'm like, okay, well, their whole model falls apart. So the other thing that I was going to say is, it would be really interesting to know how much of this, how many of these statistics are skewed by, say, the federal government, for example. Who was it? Was it Doge? Someone was catching a bunch of shit about tons, so much money spent on ServiceNow. Oh, wasn't it? Correct me if I'm wrong. Did Trump issue an informal, hey, ServiceNow, you're ripping us off, you should pay us back? I thought I saw something like that. My point is, I wonder how much of that is skewed by massive contracts where the software is not actually used. And that happens in every space. We're talking about medical. Same thing happens with big research facilities. They have all the licenses for every piece of software. But if you look at the actual usage, pretty minimal. So I wonder how much of that is really skewed. And you have providers also like Cloudflare, for example. I love Cloudflare. I talk about them. They provide really, really cost-effective solutions for if you're not a massive enterprise. And they kind of, from what I understand, they basically bank on the bigger enterprises to pay the bills for for everybody else, is what it sounds like to me. So as people are starting to understand what what you're saying and what we're talking about with the whole SaaS model being disrupted, yeah, I don't know. I just think that it's really skewed, probably. And
I was listening to an interview with Aaron Levy, who's the CEO of Box, and his view of the way this is going to propagate out into the enterprise is interesting, because he said he was there for the first wave of cloud, right? And his whole thing was trying to convince everyone that cloud was going to be the future. And he said that there was a wide spectrum of CIOs, CTOs that just basically looked at it and said, some of them were yes, some of them were in the middle, like typical adoption curve. And he said, this for AI, it's completely opposite to that. He said, none of the CTOs and software buyers in any of the big companies, and he deals with a lot of them, none of them are saying that AI is not going to be important and not going to change their business. It's the opposite. It's like, how can we embed this? How can we adopt this faster than our competitors in order to get competitive some sort of competitive advantage. But he does say that the adoption pattern into the pricing model of the traditional SaaS world will probably change, which I kind of agree with, which is less about the way that software has been sold, which has been more around people enablement, people enablement or people monetization, where you've got like so many seats. The seat model was what really kind of drove the SaaS world, right? Into a consumption model or into an agentic kind of like, I have one seat, but then I have the ability to manage so many agents or so many executions that are autonomous. Like, that's pretty exciting, but it's going to require a complete transformation of the business model of a lot of these SaaS businesses. The other thing to mention, like you mentioned Microsoft, during the SaaS boom that we've been in for the past like 20 years, the total market cap of all of the publicly listed SaaS businesses like, Cloudflare, Snowflake, all of these companies, the total market cap combined of all of those public SaaS companies was equivalent to the market cap adjusted for market cap of the three cloud providers. If you consider that like the total kind of capital, like concentration of value, even in that wave, the SaaS wave of software, it concentrated equivalent to the big players in the cloud world as opposed to the actual app layer in a comparative amount. That's like AWS, Azure, Google Cloud, and their attendant kind of services and the whole ecosystem around those. I think this is going to be worse in that those three companies are going to capture the majority of this value. I don't think there's going to be as much available for the app layer. But that's just my prediction. Yeah. Anyway, enough business.
What I
Let's
do
get on to
know
the dev
is
stuff.
licensing is already confusing enough. So if you're responsible for managing all these things, and now, and they will change, but yeah, measuring your, like monitoring your costs for the number of agents. I think Microsoft already has that on Copilot Studio. It's like you pay a license, and then you pay consumption on top of that. Yeah, it's just not fun, and it's not going to be fun for a while until they figure these things out.
Can't we just get an agent for that? Isn't that the whole idea? Yeah, the only other thing I wanted to mention before we get onto the conversation is the Cognition acquisition of Windsurf. Did you see much about this?
Drama, man. They're going to have to make Silicon Valley again, right? Or as a follow up. There's too much rich material these days. Like this story with yeah. So what happened, Tom? Tell us. It's wild.
Well, yeah. So it's like basically reverse acqui-hire for in the billions of dollars, which blows my mind. So the OpenAI deal fell over, and the exclusivity period that they'd negotiated for the $3 billion acquisition expired. Google swept and pounced on that opportunity, and they came in and they basically acquired, or so they got several key researchers and the founders, Varun Mahan and Douglas Chen, for $2.4 billion. And that included a non-exclusive license to Windsurf's technology. So basically they just became a customer. Then there's like 200, which is like just blows my mind, the amount of money. So then there's 250 people in the Windsurf team still outside of the people who went over. So it was a very small number that went over. And then they still have other assets, and they have other customers, and they had like 80 million or so in revenue coming through the business. Yeah, 82 million in revenue and 350 enterprise clients. So Cognition, so the makers of Devon, bought out the remainder of that, and it actually looks like they took care of a lot of the employees as well. So they accelerated any of the earnouts that any of those employees had. They vested all of the shares that any of those employees were potentially owed, which is quite a good thing to have done in this context. Which is interesting that Cognition wanted to do that. So maybe they're going to be stepping into the space to compete directly head on with, in the IDE space, integrating Devon. Whereas my use of Devon has been very hands off. Like it's still stayed very much a ambient agent that goes out and comes back to kind of like Codex and Claude Code to an extent. Yeah. Right. So drama, massive drama.
I have, yeah, I have a dumb question. Maybe a couple dumb questions for you, because I don't think I've even used Windsurf. It's a fork of VS Code still, isn't it? Or is it completely, or is that PyCharm? Like I guess what I'm getting at is, are these guys really even paying for IP, or they're just paying for user base, right?
So the Google acquisition, the initial one, the big one, because Cognition Labs didn't disclose how much they required the company for, right? At least not what I've read. The big one from Google, which was 2.4 billion, was basically like to get the talent and some of the effective IP, I guess, which is still embedded in the researchers' minds.
It was a
You're right. It
licensing
was
deal, wasn't it?
and it
On
was
the
a
Google
licensing
side?
deal, yeah, on the Google side. The so windsurf, yeah, you're right. They were like they were, I don't know if they were a fork or if they built their own team, but it's kind of irrelevant. It's basically like it's like a cursor competitor. But what they did is they tried to go direct into the enterprise, which is kind of why not many people in the developer community really kind of talks about it much. So all they tried to do was just go into the enterprise. So they did that pretty well. They've got 350 enterprise customers and they've been around for a couple of years. Like that's pretty amazing. They went through Y Combinator. They did that whole thing. There's a great interview with the CEO from on the Y Combinator YouTube channel if you want to check it out. They also had a couple of bespoke models and they were doing specific things to optimize the developer experience into, say, fine-tuned models like we were talking about, which is what Cursor has also done. Like they've got fine-tuned models on autocompletes and very specific tasks that make the developer workflow really high quality. So, and I believe they did it with the intent of they could go into the enterprise and say, none of your code will be leaked out as a result of using us. So that was another thing.
Yeah, but they're absolutely using it. The part I left out was I said user base. It's not just the user base, it's the um all of that training data. Like they have the more people that use their product, the more data that they have, and the better they can train models or do whatever. So that's what they're paying for, right? It's like existing user base and the amount of data that we've accumulated so far.
Yeah, actually, that's a great point because what would be underneath those 350 enterprise clients? So you would assume that they would have very strict constraints on being able to use and train anything on enterprise data, right? Or enterprise code bases. They probably wouldn't be able to use that. But what is more relevant, probably better and more valuable for someone like Cognition and Devon is the interaction data and the eval sets that they could generate off those interaction patterns for enterprise coding use cases, which is really like very, very valuable. So on that basis, it's probably incredible, right? There's probably an incredibly rich kind of interaction eval set behind there that they could use. And the $82 million, revenue is probably loose change compared to what they see as the goal, which would be driving more into the enterprise for Devon. I don't know. It still blows my mind, the figures, the money that's getting thrown around. Like it's just blows my mind.
Yeah. Well, it just goes to show, like the amount of money when these providers are saying, "Hey, you can use this product for free," the amount that they benefit off of just you as one person or one organization, far surpasses what they're spending in like GPU costs and stuff. I mean, it's so valuable they need this data, they want it, and a lot of times we just kind of give it to them, I think. So
Well, yeah, just using like in the past when you were a software user, like the interaction data that you generated was not that valuable. It was valuable to say product managers, right? But it didn't have like a accelerant kind of effect across the customer base as much as it does now. If you're a AI product builder, I think that's probably something that's now different when you're building AI enabled products. Cool. Do you have anything else on that, or do you want to get into the discussion?
yeah, let's get into it.
Cool. So what I wanted to talk about today is everything to do with RAG, vectors, and structured data. Cameron, you're my resident expert on this, and the reason why I found it a pertinent or thought it was a pertinent conversation is RAG, like retrieval augmented generation, and the whole vector store and vectorization of data went through its sort of high profile period early on in the AI boom. for a range of reasons we can get into. And then it has sort of fallen back into the toolkit of developers. And what I wanted to talk about was obviously, what is it? Why does it matter? When should you think about using these tools, how it works, and then how to do it well? The reason why this came up is that I was pushing into a specific agent problem that we were dealing with at work. And we were trying to, I guess, engineer our way to a solution. But in the end, we actually solved it very effectively just through a simple vectorized RAG pipeline, like a really simple one that actually just blew our other solutions out of the water. And so I wanted to pick your brain about it, get an understanding of it, get a feel for like what you've done in the past, what works, what doesn't. So does that sound good?
Are you able to say are
Yeah.
you able to say
Yeah, I can.
what it does? Like, can you explain the
Yeah, I can.
purpose and what issues you ran into? That'd be good. That'd be great to talk to.
Yeah, I will. I'll go through that in an example in a second. So just to back up a second and talk about like I want to kind of define a couple of these points because I think it's important. So vectors are a very simple kind of mathematical representation of tokens or data or anything into a 2D, like a high dimensional space, right? It sounds more complicated than it is. It's basically just a number that represents a word, a sequence of words, a document, a pixel, a whole image, a group of images, whatever. And it's very effective. It's a very effective data representation for LLMs to traverse, correct, and search through. So you can enable an LLM with a vector store so that it can surface or make associations more rapidly within a data set that you need it to traverse. Like, so that's sort of how I think about it anyway. So that's vector stores and vectorization. I might get you to kind of jump in a second. And then when we talk about retrieval augmented generation, basically that's just augmenting your LLM with a specific set of data that you have curated or developed or formatted in some way to drive the LLM to a certain outcome or enable it with more effective data than it had before. Is that correct? Is that a good way to think
Yeah,
about those points?
exactly. The models are trained on general information, the internet, research, whatever, but they don't have context on whether it's personal data, organizational data. So yeah, exactly. RAG, embeddings. These are all ways, effectively they're tools too, but these are all ways to make the LLMs, your agents, make them aware of your life, your business, your files, right?
Exactly. One thing I think would be helpful at this point, mate, is to just show this example, sort of make it real. Cameron, is this LLM vectorization link, this Boycroft LLM one from the show notes. So the reason why I thought this was helpful for me is I first saw this in Andre Karpathy's kind of overview of like what it looks like, what actually happens when a request goes into an LLM. And this actually shows that the vectorization process of those tokens as they go in. So basically the vectorization process happens up and down the effective activation of an LLM and in its actual kind of internal functioning. So it's good to kind of highlight that. What it actually looks like in practice is if you look at the this Nomic AI. So Nomic Atlas is a tool that you can use to kind of visualize some of these vector spaces and vector kind
And
of
that's the number one.
the
I'm
number
glad you
one.
pulled that up because I refer to this all the time when trying to explain it. Yeah, it's perfect.
Yeah. So this is really cool. These guys, they're actually a dev tool kind of provider. So they've got vectorization products and things, and they've got this product called Atlas. So you can visualize. So if I zoom in, it's like a universe, and I can see this is a Hacker News post. and you can see the topic. So there is a dot point representing a post that says, where we go, it's a post, this
Yeah,
post.
that's not a very it's not a very good representation though, because should see like clusters basically.
Mhm.
Right. I guess there you can, yeah.
Another one, well, actually, yeah, another one that I did use is UMAP. So have you used UMAP much? I think it's actually a representation kind of standard. There's a couple of them. This one's called the UMAP project. Here we go. Understanding UMAP. And this shows more of what you're describing, which is sort of like clusters. So for example, here in this example, you can see like a cluster of, this is a open data set of, it's called Fashion MNIST data set, a 784 dimensional data set of, of clothing products. And you can see the clustering representation of in the three-dimensional space. So over here, you've got, clothing like trousers. Over here, you've got dresses in green. Over here, you've got t-shirts, all of the footwear down the bottom here. This is like a vector representation that also clusters those items together. This is another kind of cool one from TensorFlow. So they have an equivalent which shows the components in a three-dimensional space. And basically, correct me if I'm wrong, mate, this is a cosine similarity kind of vector representation. Well, there's a vector representation that can be thought of as basically lots of dots or component parts, data points represented in a two-dimensional space, so that an LLM can see the similarity. So it will traverse and see components in this space that are similar to each other to make a determination when you say searching for something or trying to get it to explain something in a specific query you might feed in.
Yeah, exactly. It's all about the semantic similarity, because if you think like if it were just comparing words and doing word search, well, we don't need AI for that. That's basic search. But um, what this does is it allows the AI models, LLMs, to be so much more efficient in the way that they search, because they're not necessarily just looking for like the key terms. They have a very sophisticated map of these embeddings, right?
Yeah.
What are you showing there?
Oh, this is just the example of the, in that Hacker News, you can see like this is the title strings and where they're represented in this big universe of Hacker News. So you can actually see it's actually vectorized based on the titles and the locations across the actual space. That's exactly what you were describing. So just based on that, so I can give you a brief overview of what we were working on now, why I wanted to talk to you about this. One of the products that we have at work is a mobile inspection tool. So I work in the real estate mortgage finance kind of crossover space. We have an app that people use to inspect properties. Part of that, in those inspection standards there are very rigorous data outputs that are required by a lot of the players in the banking industry as a standardized format. The reason that's important is because there's a lot of compliance requirements around when a property is inspected for a certain purpose, in the purpose of, say, originating a loan. That has to be proven. It has to be proven that the inspection was done in the correct way by a qualified person, but also that the correct data points are captured. Now that is relatively straightforward in that it's basically a JSON schema standard. But what we don't know ahead of time is the setup of the property. So we have to define that in some sort of like data dictionary, right? So I've got two data sets where it's like, all right, I'm coming in and this property has an ADU and 2 levels and 12 rooms, of which 3 are bathrooms, 3 are bedrooms, and the rest. That then defines all of the data schema in the JSON format that needs to be forced into that kind of format to be answered. And there's lots of dependencies, there's lots of enumerations, there's lots of kind of branching. If this, then this question needs to be answered, all of that sort of stuff. And all of that is defined by legal standards, effectively, of the way that these inspections are done. And we were building a voice agent that translated natural language conversion from the person wandering around the house into that very defined JSON schema structure. And what we were trying to do was build lots of tools, which we have done, and that was working. But I was thinking, I think this is why I thought the conversation was pertinent, is because I was thinking about this as a reasoning kind of translation problem, almost like using the intellectual grunt of like, and getting distracted by the shininess of like these new models to derive an intelligent response, or derive the intelligent response out of the person's kind of natural language and convert it into this standard, this inspection standard. But actually I was thinking about the problem in the wrong way. It's just a search problem. And as soon as we pivoted to that, there are actually very lightweight models that are now on the Apple kind of the new iOS release, these Apple kind of models on device. They're actually very good at this and can do it on the little inference chips that they've got into the modern phones. Right, we can do it in a much simpler way using these what are now older kind of tools, like a very simple vectorization of the JSON schema and the data dictionary, and then just force that, like basically push the natural language into a vector kind of search space, and then have like basically a probability response. I think a lot of the stuff that we
So
work
you've
on.
taken, just to make sure,
Yeah, go on.
just to make sure I understand, you're talking about taking a voice, what transcript or whatever stream, unstructured data, and then fitting that to a JSON, basically metadata, right?
Yeah, effectively. So, for example, Cameron, you wander into a house and you're like, we don't know, as an app, we don't know where you are in the property. We don't geolocate you, right? So you could be out the front and you could just be talking about the roof material and the roof quality, or the street view, or the potential damage that's occurred. All of those things that I just described, and you might describe it in one long stream of consciousness to our voice assistant, and we need to traverse over every single thing that you said, and then search within that sort of potential matching criteria in the JSON schema, and then decide if we've got enough confidence, if the LLM has enough confidence to make a determination that that's actually what you want it to be set at in the effectively the inspection form. So that's the challenge.
Right. So the part I just want to make sure I understand. So you are using a process. You already have that JSON template, essentially, right?
Yeah,
It
and that's
defines your
an industry
fields and your
standard.
form.
Yeah,
Yeah.
that's an
So
industry
then
standard.
you have a process that is pulling in the entire transcript of the person talking, and then it has I would assume, based on it's like prompt engineering that says identify this is the criteria from our form that we're looking for. If you find this, put it into this JSON format. That's like step one. Is that what you're describing?
and then
then
populate a file, like a report file with that. So fill it out. Yeah. But we do it in real time. So it's not
right.
like
And then
the
you're
whole
talking about
transcript.
embeddings.
Yeah, it's not the whole transcript. It's actually in real time. So it's like you say something, it might be a comment, whatever, and it's like in a chat interaction. And then there's a turn, like an LLM turn in the chat interaction, and it takes that away and says, yeah, okay, based on what you described, there's and what I can reason down from your natural language is that the fields that we can fill out based on this information are this, and this. And even though you described it in natural language, which was just like, the windows look a bit shabby, that translates to this very specific industry standard schema in natural language conversion. And we've annotated that with metadata, as you described. But
right. So at what point are you doing the embeddings?
well, so what we were actually doing, the approach I had prior was like I was building like a LangGraph, multi-level agent to try and achieve this. And then there was effectively like a supervisor agent that would engage with the person on this chat or voice turning, so text or voice. And then it would pass off to effectively a determination kind of sub agent. And then that process would engage with tools that triggered into the JSON schema, and then there was a translation kind of standard that would say, all right, when someone says this, often that's based on an eval set that we were building up. An eval set, often that means if when someone says like, oh yeah, there's hardwood floors everywhere, often that means set all of the hardwood floors in every room except for the bathrooms, because bathrooms typically have tiles in them, right? We were trying to do it like that, but actually, and that was quite complicated. The other factor is it took a lot of prompt engineering, and the prompt engineering was kind of challenging. And also it meant that we weren't able to use these lightweight on-device models that are coming through for mobile devices because we needed the intellectual grunt of these frontier models. But actually, none of that was as effective as just having a very simple short prompt. You can even use the on-device models. They're not as good, but you can get a long way there. And just put all of these JSON fields with the metadata into a vector, like vectorize them, and just let a very simple model say search for the right field. That was way more effective than all of that craft and all of that AI engineering over the top. That's where we're at now, effectively. So that's a very long-winded way of saying the reason why I wanted to have this conversation is like, I think we've kind of forgotten how powerful these things are and how they have an application in more context potentially for AI engineers than we think. Would you agree with that? I don't know, like you use it a lot, right? Like, you've done a lot of projects like this, and you've built
Yeah.
a range of different things.
Yeah, what I heard you say in the simplest thing the simplest form of repeating back what I heard you say is that you didn't have an ETL extract transform load process, and then you figured out you needed one. That's what I heard.
Yeah. Well, that's interesting you say
Does
that, because like
I
the
don't know if you
data,
agree. I
well, maybe you're right. Like the reason why I thought I didn't need anything like that is because I thought the data set was small enough. Like the JSON schema was small enough. It's like what, 500, 600 fields, with enums and then a variation of the number of those that are in there. Like it's not massive, right? And I thought, oh, we don't really need it. Like it's not big enough. I thought it's big enough for the context window. But actually translating the JSON schema into this vectorized format made the LLM way more effective than anything else we did. The other thing, yeah, so, when, I guess this question is I wanted to ask you directly is when is this RAG pipeline and vectorization relevant now? Like, if you're an e-commerce store, yeah, it's right? Like if you've got a massive search space and you need to do that and you do recommendations, like it makes more sense. But like I didn't think it was relevant, but it is relevant. So like, what do you think? Like, when should engineers be thinking about these tools?
Yeah, I mean, context window is a massive part of that decision making process, right? So just raw volume of data. I think that's pretty obvious, though, right? I mean, do you have any example specific scenarios of because that's like so broad, when should you use embeddings and vectorization versus not? That story that you just described about basically extracting data and extracting metadata and then running searches or embeddings over that information is a very good approach. The hard part about that is that it still requires like your old school, or I shouldn't say old school, but it's data science really at the end of the day. And we have all these all these models are getting better all the time, all the time. So there's a tendency, I think, for people to just say, well, let's just shove everything through the LLM and it's capable now. It'll figure it out. What you end up getting in reality is you'll get a bunch of information that looks really good. But as you dig into it, you'll notice there are a lot of problems with it. So I'm a huge advocate for taking unstructured data and turning it into structured data. But like I said, one, that takes a good understanding of what your data is. And two, that requires, in most cases, building infrastructure for your ETL process. And it's not as exciting because it's not a new thing. So you're not going to necessarily win deals saying it, like walking in and being like, yeah, we need to set up some traditional ETL pipelines. But that's the reality in my experience.
Well, I think that's great. That's good. And that's sort of what I want to dig into. Like, you're going to win deals if anyone will, when you say, I can solve your problem. I think like it's important for engineers to know like how those things are solved effectively, regardless of the tools. Like, I think we all got distracted by the fact, and we talked about it earlier, like there's big context windows, like is RAG dead? It's obviously not. What is a good ETL pipeline kind of structure look like? Like, how do you think about building that? Like, what's the framework? What's the mental model? Like, how does it work? First up, what is it? Like, define it in practice what an ETL pipeline actually is, like a good ETL pipeline.
Sure. Yeah, well, ETL stands for extract, transform, load.
Well, here's an example maybe I can pull up. This is like from some of the guys that we follow a bit. We have talked about this project before, which is doc ETL, right? Maybe this will kind of illuminate some of it. So this is one of their examples of their papers, right? So at a high level, like an ETL pipeline, obviously
Oh,
applied
yeah,
to
that's a great example.
it's applied to your use case, like your problem set, right? So obviously this will always change, but for them, this is US presidential debate analysis, and they wanted to build an ETL pipeline for those documents. And here are the high level things: basically map each transcript to the themes that emerge from those debates, then extract those themes into a workable format, deduplicate and merge it all of that data, and then push it through some sort of analysis pipeline, right? So that you would describe that as an ETL kind of process, right? And effectively,
Yeah, and
you're
this is
taking
a great
like the raw
example.
data
I'm
and
glad you.
pushing it over to an area where it becomes usable data. That's the high level kind of summary, right? Like not usable, usable.
And this is a great example. The thing about this example, though, is that they have taken a traditional ETL process and injected a bunch of AI and agents into it. I'm not even necessarily talking about AI. Does it have a runnable? Are you going to be able to run that?
No, I'm just clicking around, man. I'm just clicking around. I do have an example that I can show you from
Yeah.
Superlinked, which is this is a startup that I've been following for a while, which does, it's like it's like they call themselves a vector computer, but basically they try and give you more parameter control over the top of a vector, like of a vectorized data set, so you can do search more effectively. But that still doesn't answer the question which we're on now, is like, how should I think about taking a data set that I have and making it an effective pipeline to get it to a point where I can push it through some sort of vectorization process? Like, usually what I've read or seen, and correct me if I'm wrong, is that basically there's the simple processes of like taking your raw data, thinking at a high level what the outcome you want to be is, whether it's like content discovery or search for the user, whatever it is. And then there's predictable kind of processes between there. Things like deciding on how you're actually going to chunk up the data and extract the data, whether it's like unstructured or structured data. If it's text, if it's just all text, that's fine. But if it's documents that have like charts and words and relationships or a blend of those, then you have to think about how you extract that data and kind of make the relationships. Then there's the process of vectorizing or putting that into that data format, and the overlaps and the chunks of each kind of chunk of the data, whether it's text and the overlaps for that, or how you make images, how you vectorize images, and how you kind of process that kind of data and make the relationships, how you add metadata, and then how you add it into effectively like a store or a format for you to basically engage with. Those are the ways that I've kind of, at least seen it described.
Yeah, Tom, when it comes to embeddings and retrieval augmented generation, this is really the first area that I jumped into myself when it comes to AI, apart from ChatGPT, but actually coding. And the reason was because it was so relevant to what I was doing at my job. So I was building tools, RAG tools myself, just to be able to improve the efficiencies and the quality of data that I had at my job. So I saw that firsthand myself. I was like, man, this is absolutely insane if you can roll this out throughout an organization. So right away, I bought, what was it? NVIDIA released Chat RTX, the desktop application for RAG. So I bought an NVIDIA GPU and I set that up, and pretty much right away I was like, well, this isn't going to work for what I'm trying to do. So that's when I started coding it all out. And then from there, I really got into a lot of the, are you familiar with Greg Camrat? Of course you are. We've talked about him here. Yeah. So he actually did a lot of the early work on LangChain documentation or LangChain tutorials. He has a channel, some websites called Needle in a Haystack. And if you're interested in RAG, I mean, this is probably a couple years old at this point, but the concepts are totally applicable, and his content is really good. So, little shout out to Greg there. But I started studying his information that he was putting out, and that really, really piqued my interest. So, I would say, as far as projects that got that I attempted and quickly realized that I had the wrong approach, were around email. I think was the first one. So you think about email. I guess it depends who you are. So there's a wide variety of email volume, internal, external, et cetera, et cetera. I mean, I think I think it's safe to say that email probably has the um, some of the highest number of variables as far as like what kind of data you're dealing with. So, anyways, I jumped into that. Um, And I quickly realized that that entire process required a long ETL pipeline before it even hit the AI. And that was for like data cleaning. So things like dates, even emojis, um, different types of formats that come through email servers. Um, so the way I got around that was, Tom, almost exactly what you're describing with the JSON. So instead of taking all of that content and sending it through the LLM and the embeddings process. Uh, in my instance, I was already dealing with structured data because it was linked directly into the email system. So instead of taking all that raw text, you might just pull out the sender, the receiver, the body, who they work for, like whatever attributes you want to identify. And then you have much, much less data. It's much more efficient. And then on top of that, you can process it so many different ways. You can embed it for one, and then you can also layer your RAG process. I think generally people think of RAG just as like embeddings or vector search, but that actually includes SQL or graph RAG as well. Do you know? Have you done much with graph RAG?
I just explain what that is.
Um, Yeah, it's somewhat related to the embeddings. You showed those visuals where it's basically creating clusters based on semantic similarity. So you can do some amazing things with a graph database. Uh, I'll just try to hit it. Think of it like the embeddings visual you showed is using semantic similarity and cosine variability, things like that. A graph database is very similar, except it's going to create what are called nodes. And those are generally going to be like a noun. So people, places, things, whatever you define, and they're connected by edges or relationships. So my point is that if you have designed a proper ETL process, you can make it so much more efficient for your LLMs and your agents to find that data.
The leading database for that is Neo4j, right? We spoke a little bit about this when we were talking about the memory store. So some executions of, a great LLM memory rely on, or they have made a bet on a graph representation of memory in order to accelerate the ability for an LLM to retrieve relevant contextual information about the user or about the query or about the preference, right? That's very good for that sort of thing. It's also very good for a representation of things like social graphs, or there's a lot of use case for those things in very large big data kind of areas where you're trying to analyze, say, fraud detection, like seemingly random interactions on a platform that may have relationships that are hard to identify, but a graph extracts those relationships well, is the way that it's positioned.
Yeah, exactly. And the part that potentially gets missed sometimes is the fact that, sure, you can store or process all of the raw data. And if you're talking about an organization, you're generally storing that data somewhere anyways, right? Whether that's a database, um, then your SaaS application, and you're using API calls. But the point is that you can use like metadata embedding searches, and then as still within a second part of your process, you can still use like SQL or whatever graph rag, so that you're just using the embeddings to find that first tidbit, that first helper, the pointer, and then your LLM knows, okay, it's related to this. So now I can use SQL, or I can use another
Yeah.
tool to go find the entire detailed set, right? So like doing similarity search on particular words, and then the LLM says, oh, okay, I see this is actually in this table in SQL. Now I'm going to use a SQL tool, and I'm going to find all the detailed information that way. For me, it's all about like understanding your data and creating various layers of data.
So
If you
that
just
takes
want to
me
do
to like,
if you just
yeah.
want to do a single RAG database, oh, I'm sorry, Tom, go ahead.
Well, sorry to cut you off there, but that actually takes me to a question I had directly for you, which is, do I need a dedicated vector store, and what are the performance benefits of that? Like a Pinecone, where I have to take on like admin overhead or infrastructure overhead, or can I get away with, say, super base PG vector plus my regular SQL kind of execution for the back end? Like, why are there these dedicated stores for this? Why isn't it, say, just the Mongo's execution or the PG execution winning? Like, are there benefits, or is it overblown?
It's definitely not overblown. It just depends on your use case. But I think, that's my point, is make sure you understand your use case. A lot of these online hosted platforms, I think like even ChatGPT, you can upload your documents, right? Is that accurate?
Yeah, they have like little stores
Yeah.
and they
So,
vectorize
and
it and they put
maybe,
it through the text embeddings, but it's like it's pretty narrow band. Like it's like session based or like user based. Like you'd be hard pressed to use it, I'd say, for anything that's scalable.
yeah, that's exactly my point, is you will see, like if you've done any of these, upload your files and it embeds to your like little vector space. It works for a while, but it's relying strictly on that method is not going to work for mass amounts of data. I think most people realize that now, but and maybe that will change. Who knows? I don't know what capabilities will come out in the future, so I can't say that's always the case. But if you think about this, OpenAI, Anthropic, Google, all of these companies could, or I guess I should say, why don't they vectorize and store all of your data? Because they could, right? But it's not necessary. So if you're doing like a common use cases like a customer service chatbot. So you might have a public facing customer service chatbot and it has some knowledge base articles um, on very specific things, right? That's pretty straightforward and it's not going to require a ton of data. You don't need an entire database to be able to answer some simple questions, right? Tom, what you're talking about, like in the real estate example, and I don't know where the data is stored or how it's stored, but you're probably talking about a ton, like thousands, hundreds of thousands of potential files, right?
In aggregate, yes. But in the context of the query, no. So I was like, oh, well, it's too small. It's too much of a small kind of domain data set to bother. But actually, when we tried, vectorizing it made the performance excellent, better than trying to prompt engineer our way to success. So I kind of fell into that camp. I'm like, basically of like, oh, if it's a big challenge, if there's lots of files, then that's when I should go there. I was surprised. Because the actual search space is in the context of a person in a property, but that property is one place, right? And the data set is maybe 500 fields times, 500 potential fields in a definition set times, one property about, it's probably not that much, and all of it can be handled in probably, I don't know, 2,000 lines of JSON. Like it's not a lot, right? Or it didn't feel like a lot. I think it's interesting, like this vectorize, like when to use it. Like there's obviously narrow cases to use it where it makes it more effective. So when we did the talk about VO3, when VO3 came out, in the documentation for VO3, they talked about how they get character consistency, so through scene to scene. And one of the ways they do that is they take the actual character component and they vectorize it into the generation space to make sure, like, so basically to try and generate the character from scene to scene with the same, facial features or whatever it was. So there are very narrow band applications where vectorizing data makes sense in the context of generation, like AI generation. It's just a domain that I kind of underestimated, I guess. I kind of feel like I underestimated its application in the things that we need to build today. It still feels like based on that experience that it's still more relevant than ever.
Yeah, and that's kind of what I meant, Tom. I think it was last week we were talking about local models. I said something along the lines of there are definitely use cases for them. It's just a matter of figuring out what they are. And this is one of the things that I meant by that is like just extract your metadata or maybe like a summary of something. And these smaller models, they can excel. They can absolutely do that for you. So I do actually quite a bit of that with like local models. I'll just extract the key pieces of information and you can do a lot more than you think.
But I reckon we wrap it up there, man. Like, so that's really helpful. I found that really helpful. I think it's something that is important to dive into if you have kind of forgotten or either dismissed it as applicable to whatever you're building. That was my experience this week. So that's why I wanted to chat about it on the show. The other things that I found interesting were some of the solutions around how they actually execute some of these conversion pipelines into the vector space are interesting and are emerging of things that I haven't really engaged with, like Pinecone, for example. They talk about some of the algorithm processes that they have and the variation depending on the kind of problem space you're going into. The benefit of that is obviously they do it for you. And then Superlinks is that other product that I have seen where they try and basically they're positioning themselves as a rapid re-ranking based on search queries that you can execute, so you don't have to effectively recalculate or re-execute. You can do it on the fly based on search queries that go into their quote-unquote vector computer. So yeah, check both of them out. But yeah, do you want to wrap it up there?
Yeah, and I think just to tie back to a previous episode, we talked about Mem0 and MemOS. So I mentioned like creating a layered approach. And I think although they are specifically applied to agent memory, There's some of the best examples of, I guess, what I'm trying to get through here as like a multi-layered approach. So go check that out if you haven't. They have some really good papers written about that.
Yeah, let's chuck it in the show notes. All right, mate. This has been great. Another episode of the Build Out. Thanks.
Thanks, Tom. Smash and subscribe.